Hi, in this video we are going to talk about the main differences between the stack memory and the heap memory. And basically, stack memory is the most important applications of the stack abstract data type. It is a special region of the memory in the so-called random access memory, to be specific. And a call stack is an abstract data type that stores information about the active subroutines or methods or functions of a computer program. This computer program can be written in C, C++, Java, and Python. Basically, it is the same for all of them, the so-called call stack or the stack memory and the heap memory. So the details are normally hidden and automatic in high-level programming languages such as Java or C#. You may pose the question that, okay, why is it good, these stacks? What is it for? It keeps track of the point to which each active subroutine should return control when it finishes executing. So basically, stacks store temporary variables created by each function. Whenever we create, for example, two numbers to add them together in a distinct function or method, then these variables are going to be pushed onto the stack. And whenever we return from this function, the stack is going to get rid of these variables. So the local variables are going to be stored on the stack. So every time a function declares a new variable, it is pushed onto the stack. Whether it is a reference type, for example, in Java, or a primitive type, it's going to be pushed onto the stack. And every time a function exits, then all of the variables that's pushed onto the stack by that function are freed. Stack is going to get rid of these variables. So all of its variables are popped off the stack and lost forever. And basically, this is what we have been discussing, that what kind of operations do stacks support? Pop, peek, and push, basically. And basically, that's how a stack can get rid of the variables. It's just going to pop these variables off the stack. So local variables, they are on the stack, and after a function returns, they are lost forever. It's very important that stack memory is limited in size. Basically, it is quite intuitive because it is inside the RAM, the random access memory, and the random access memory itself is quite limited, so of course stack memory is limited as well. What about the heap memory? The heap is a region of memory that is not managed automatically for you. It is in the random access memory as well. It's very important that this is a large region of memory. Unlike stack memory, because we have been discussing that the size of the stack memory is very small. In C, for example, we have to use the malloc and the calloc function and with the help of pointers to be able to allocate some space on the heap memory. For example, when we would like to store a huge matrix, of course we are going to be able to store this huge data in the heap memory, because I don't want to repeat myself over and over again, but the size of the stack memory is limited. The stack memory is faster than heap memory, but the size is limited. In Java, reference types and objects are on the heap. So whenever we instantiate a class and we create an object, then it's going to be added to the heap memory. So we have to deallocate these memory chunks in C++, for example, in C, because it is not managed automatically. We have been discussing the stack memory. The stack memory is going to be managed by the operating system, so we don't have to bother about it. Local variables are going to be popped off the stack no matter what. We don't have to do anything. Here we have to bother about the content of the heap memory because the operating system is not going to manage it for us. So if we are not going to use an object, for example, then we have to remove it from the heap memory. And basically that's why the Java garbage collection operation came to be, in order to get rid of those objects from the heap memory that's not being used. If we do not get rid of these objects from the heap, this is what's called a memory leak. Memory leak basically is the situation when there are dead objects on the heap memory. We do not use these objects and classes, but we have forgotten to remove them from the heap memory. And because it uses pointers, that's why it is slower than stack memory. So just to summarize again, we have two types of memory, the stack memory and the heap memory. For all the programming languages, these memory types are present. Okay, sometimes we don't have to bother about it. For example, in Java, we just use local variables, we just use primitive types, we just use objects, we instantiate classes, we use objects, we don't have to bother about it. But under the hood, on the low level, stack memory and heap memory is going to be used. In C and C++, we have to manipulate stack memory and heap memory. But for high-level programming languages, C#, Java, Python, we are not going to bother about it. But I think that it's good to know something about stack memory and heap memory. So the stack memory is limited in size. For heap memory, there is no size limits. On the other hand, stack memory is quite fast. Heap memory is slow, so basically there's a huge trade-off between running time and memory complexity in the sense that, for example, stack memory is limited in size, but on the other hand it is fast. Heap memory, there's no limits, but it's quite slow. We usually store local variables on stack memory, no matter that it is a primitive type or a custom object or whatsoever. It means that we store local variables in stack memory. And we store objects and basically field variables in heap memory. For stack memory, the space is managed efficiently by the central processing unit, and for heap memory, it may become fragmented because it is managed by the software engineer and the programmer. We are not able to resize a variable on the stack memory. As far as the heap memory is concerned, variables can be resized with the help of the realloc method, for example, in C or C++. So basically these are the main differences between stack memory and heap memory. In Java and Python, we don't have to know much about these memory types, but I think it's good to know a little about these memory types. Thanks for watching.